All right, so we're here for the part 2 of One's Island. We got a solution object here. The solution object takes 2 grids. This is the One's Islands grid right here. And it also takes another grid, which is, it's a grid that's the same dimension as this one's. And basically, every cell in this grid maps to the other cell in the One's Island grid that they share the same row and column. And this one is just basically a flag, a Boolean flag, which indicates whether the ones in the One's Island is an already discovered island. So every one, once I discover it, I'll switch the corresponding row column in this grid to true, which means that island has already been counted, and the island count will not be incremented, because then we would have a false I guess island count. All right, so here we have our main function. What it's doing here is capturing the dimensions of the One's Island grid. So this is the height, and this is the width. Then here we're doing a for loop where we're gonna visit every cell in the One's Island. So here in this if, we're checking if this is a 1. If it's a 1, that means this is new land, and the discovered bit is false. That means this is undiscovered land. Then we increment the count because we just found a new island, and then we recursively explore it with the helper method, or the function here. And here is what this function basically does. First here, it checks if the column and row are within spec. We can't have negative rows or columns, and we cannot have column numbers that are higher than the dimensions of either of the grids. So once we have verified that, then we're gonna, again, because this is recursive, we're checking again, is this a 1, and is it discovered? Is the discovered bit false? If it is, then we're gonna mark it as discovered. And then so remember we were talking about here how every cell in the center is gonna have 8 neighbors, 3 on the top, 2 to the sides, and 3 on the bottom. So what we're doing here is we're calling this function recursively on each one of those neighbors. So here n-1 and m-1 is kind of saying like the bottom left neighbor, recursively start exploring that one. This is the left center neighbor, I think, and on and on and on like that. So it goes through here, marks this as a discovered island, but it only increments on the first one. But when it's recursively doing it, it's just gonna mark all of these ones. The discovered bit will be true, because initially all the discovered bits are false, but these are all gonna be true. So later when we are going through and checking for more islands, we already know that this island is counted already. Like this one will never be marked as true because it's not part of this island here. All right, so once that happens, basically, once we're done flagging all the islands and counting them, we're just going to return the count. So here, this is the same example I did on the whiteboard for the first part of this coding exercise. So we got one island here, one long island, and then one isolated small island on the upper right corner, and then these two islands. So it should read 4 once we run this. All right, let's see what it says here. Correct, 4. Now I'm gonna delete this island here and turn it into a 0, and now it should say 3. Yes, so basically that's the whole solution.